I will continue. Yeah. So my research team, so my co-workers were working together with hydrogen economy and different aspects of hydrogen economy. And we believe that at present it's very important to discuss the hydrogen supply chain. Therefore, today my idea is to give a short overview of the state of the art, but already previous speakers covered many points, so that's why I will escape, and also give our vision to the hydrogen economy in the near future and with perspectives. So actually, third hydrogen wave came because hydrogen can be the solution for deep decarbonization, not only energy sector, but also metallurgy, transportation, and so on. So hydrogen, if hydrogen economy will be very well established and became full reality, so can contribute to all five goals of deep decarbonization. And since we're discussing about hydrogen economy, definitely hydrogen supply chain should be discussed. And we know that supply chain in general, it is everything from the production, regardless how this fuel will be produced, particularly when discussing about hydrogen and how it can be used. And this is very nice idea was, this graphic was developed by Siemens Energy in Germany, and we clearly should distinguish between upstream, so it means production, midstream, transportation together with storage, and downstream is the use of the hydrogen. This is really very interesting that the use of hydrogen we already know, and it is very well known for us how efficiently can be used hydrogen if hydrogen will be available. During the second hydrogen wave, as I mentioned approximately 20 years ago, that was intensively discussion how hydrogen can be produced. And now we are facing the biggest problem, how hydrogen can be transported. And when we discuss about hydrogen production, it's always very difficult to explain hydrogen production methods and technologies. Therefore, concept of color scheme that was also applied for hydrogen. And very often we just mention, for example, green hydrogen, blue hydrogen, and immediately people will understand what it means. So it means that hydrogen this code or hydrogen scheme is very good for communication and for clear understanding of production methods, not the entire chain. And this is very interesting that Mitsubishi Heavy Industries, for the first time, they proposed so-called hydrogen rainbow. But unfortunately, this idea did not exist a very long period of time because people already started to discuss many different hydrogen production methods and particularly combination of these methods. And this is also with the same company. They proposed hydrogen color rainbow. To extent it is hydrogen color wheel. This is also many production methods of hydrogen, but only pure methods of hydrogen production. And in this period of time, I discussed it in my research group, and we found out that color wheel is, of course, interesting approach, but it is not something natural. And we would like to discuss something natural like a rainbow, but include all hydrogen production methods. And from this work came our idea. It is idea of university, so Technical University Berlin, my university, and my research group. It is peacock of hydrogen. We know that this bird is very colorful, and in general we can assign using this natural colorful idea we can discuss all hydrogen production methods. Therefore, when we discuss all these colors of hydrogen production, it will be involved with not only how sources coming to hydrogen production, but also how molecules coming to finally to produce hydrogen. Also technologies and carbon intensity of all these methods. We published a paper, and at present this hydrogen color code is the wider that we proposed in to the International Society to discuss hydrogen. Definitely, all of these methods have advantages and disadvantages, and we conducted multi-criteria analysis, including, of course, cost and environmental impact of all methods, but also very important to discuss technology readiness level, because we can optimize, we can predict cost, we can assume something, but very important always to discuss which technologies already exist and at which level these technologies exist. And also very important that we should discuss large scale hydrogen production, because it is should be worthwhile. So we discussed which countries produce it and have idea to produce which kind of hydrogen, I mean, using the color code. And the most important is that, unfortunately, countries that produce hydrogen and countries that would like to use hydrogen, they are far away from each other. And the first presentation, we already listen about hydrogen market in Asia, that definitely we need to use a long transportation between the countries. So now to come to the transportation, because usually we assume that transportation exists and we can use other facilities and infrastructure, but in fact it is not absolute the same, and we need to pay attention to very special properties of hydrogen. So hydrogen in general can be transported using three options: with pipelines, in compressed form with railway or with trucks, and also in liquefied form with tankers with a long distance of ship transportation. But liquefied hydrogen requires one more option. It is regasification of liquid hydrogen, in similar to LNG. Okay, and about transportation, we cannot ignore this topic of transportation, because if we will conduct life cycle assessment, does not matter, it will be from economical point of view, or energetical or environmental impact. Transportation plays very important role, in transportation always will be included in the analysis, because transportation, it is the midstream of fuel supply chain. And now I would like to give a little bit more attention to the all technologies for hydrogen transportation, and for which scale these technologies already exist. So we will continuously use this scale of technology readiness level, and we know that there is level 1, it is just idea, theoretical idea, and level 9 is already full practical application. And if we discuss about hydrogen economy, definitely we would like to be at the upper part of this scale. So let us discuss now technology by technology. For pipelines, hydrogen supply using pipelines, and also hydrogen supply and using compressed gas form, we have technology readiness level between 8 and 9, so it means full industrial application for all scale, small, medium, and large scale. So it means from this point of view, we can say that this is not a problem to supply hydrogen, because technologies exist, and okay, pipelines, not full infrastructure exist, but compressed gas definitely can be supplied using railway and also truck transportation. And we know that there is already European initiative to convert quite a lot of existing natural gas pipelines to hydrogen pipelines, and also produce new pipeline net for the hydrogen transportation. Let us discuss about liquefied hydrogen, because liquefied hydrogen it is the option for transportation for the long distance. And we know that the highest technology readiness level exists only for small scale Technology readiness level 7, it is at the level of pilot plant, exists for medium scale, but for large scale, still we are with theoretical discussions, we are with still not established infrastructure that we can discuss that transportation of hydrogen in liquid form, it's easy and can be applied between different countries. And very interesting that when we discuss about progress in the transportation of liquefied hydrogen, we will not discuss about energy consumption because energy consumption is fixed for the liquefaction process. But we need to discuss how to reduce the cost. So it means that many optimizations should focus on the cost, but not on the energy consumption, because I will repeat, we cannot do much with decreasing of energy consumption. Okay, let us move now for the storage. Storage of hydrogen, just stationary storage, for example, at the place of production or at the place of where hydrogen further will be used, exist at higher technology readiness level for all capacities, small, medium, and large, but the transportation of hydrogen small and medium scale, because we never discussed it large scale capacity, simply because it was not required, and now it is required, and we need to discuss these technologies. Another aspect, like transport of hydrogen in liquid form. Our idea, of course, to use tankers similar to LNG, but we should clearly say that at present we have only one tanker with small capacity, and this is Kawasaki production. It is only for to demonstrate, it is pilot plant. Therefore, to make any of the optimization, any prediction of cost for the liquid hydrogen transportation, it's very difficult because we have only one particular example when we have proof of this technology, and this technology will work. Unfortunately, no more examples that we can subtract some data. And as I already mentioned, if we discuss about liquid hydrogen transportation, we need regasification. Regasification exists only in small scale. This is quite popular, similar to regasification of cryogenic liquids such oxygen and nitrogen. This is well known. But for the hydrogen, there are only few examples in the UK of medium scale. Large scale regasification does not exist. And my research group, we are doing actually the first attempt in this direction to discuss the large scale regasification of liquid hydrogen. And now the transportation of hydrogen to the long distance, not with ship transportation, only with ground transportation, with pipelines or with trucks. And we can see that if, for example, if any of gasoline fuels, methanol or propane or any other fuels will be transported with the truck, then 65% of the mass of the entire truck with fuel, it will be fuel itself, and only 35% it is truck. But in case of compressed hydrogen, it is only 1% is fuel and 99% it is just transportation of the vehicle itself. And for the liquefied hydrogen, it is 7%. So it means that during the transportation, actually, the largest weight of transportation, it is truck itself, but fuel, it is a very small part of the weight. Okay, now we also should discuss leakage of hydrogen during the transportation. For example, 1% of the stored hydrogen, it is leakage during the storage, and with pipelines we have 0.5% per each 100 kilometers. And if we would like to transport hydrogen to very long distance, we should keep in mind this leakage, and also in compressed gas. Much more problems we have with the liquid hydrogen, because we have boil of gas, which is not deeply investigated at present for liquid hydrogen. We know this problem because of LNG, liquefied natural gas, but everything which is related to hydrogen still should be evaluated, and also loading and uploading, we have leakage of 5% of the amount of hydrogen. So this expensive fuel, we continuously will have the problem. And all these problems, or better to say challenges, that we have with hydrogen economy definitely brought us to another status, that we need to discuss alternatives. So long distance transportation of hydrogen will cause a lot of problems, and we don't know yet environmental impact that will be associated with that, and also risk analysis. This can be a big discussion and research in the field of risk of hydrogen. Therefore, we have alternatives. We have methanol as energy carrier that with a very high percentage of hydrogen. It can is a hydrogen transportation inside of chemical substances, and also ammonia. And again, I will refer to the first today our presentation, because I already mentioned that methanol and ammonia could be the most attractive ways for transportation of hydrogen inside of chemical substances. And actually now we're discussing more and more attraction of ammonia as the fuel and chemical substance that contain a lot of hydrogen, and after that always through cracking of hydrogen, ammonia through cracking of ammonia, hydrogen can be liberated from ammonia, and ammonia can be used as a fuel rich with hydrogen, and also hydrogen can be used as a pure fuel. And the last what I would like to say, that if we would like to proceed towards hydrogen economy, definitely we need to discuss energy aspects, so how much energy required to produce hydrogen, transport hydrogen. Also, we need to discuss economic aspects. We should discuss environmental aspects, but we need to discuss everything together. But on top of that, should be always addressing the technology. Technology exists or technology does not exist. And if technology does not exist, maybe makes sense first to look to the technology, technical realization of this technology, and after that we can discuss already if this technology is economically meaningful, environmentally friendly, and thermodynamically efficient. But first of all, should be meaningful of technology. And the last slide, thank you very much for your attention. Sorry, I need to talk a little bit faster because we lost a little bit time with technical issues. And my special thanks to my co-workers, two ladies, Dr. Jimena Inser and Master of Science Amira Karayem, these two my co-workers who developed this fantastic idea of peacock, use it for the color scheme of hydrogen. Thank you very much. And I'm looking forward for your questions.
Thank you, Professor Morosuk. Thank you very much. Now we are a bit late, so I would like to kindly ask any questions to go in the Q&A, and Professor Morosuk will kindly follow up with them there,
yes,
if that's all right, so that we can get back on track. Thank you again, Professor Morosuk.